So today we start Gauss's law and its application. Okay. So here we start Gauss's law. Law and its application. Okay. So that's a very important in board exam. Okay. Gauss's law. So here just we discuss the formula. So first we formula know that electric flux. Electric flux. Okay. What is electric flux? So electric flux signifies that number of electric field passing a some unit surface area. Okay. So here suppose we consider a surface like suppose we consider this as like a surface, and here that electric field, and that is a number of electric field. So here we write that E is represent the electric field, obviously vector field, and suppose this surface is a ds surface. So that is electric flux represents the phi, that is equal to, okay, that is that closed surface integral. This is the closed surface integral, obviously, that is E dot ds. Okay, that's the electric flux. Okay, and now next formula we discuss is the Gauss's law. Gauss's law. Okay. So before we start discuss Gauss's law, first clear the concept what is the electric flux. Okay, and this electric flux is related to the Gauss's law. How? Because that is surface. Here we see they discuss a surface. This is a closed surface, and this closed surface enclose some charges. Okay, and if I say that is a phi, that is E dot ds, and the charge enclosed by that surface. Okay, there is not an open surface, this is obviously a closed surface. So this q enc support, I say that is an enclosed charge by the surface. The surface is ds by epsilon naught. That's the Gauss's law. Okay, and that's a very important concept. What is the Gauss's law? And now we discuss another formula, the field of a uniformly charged ring on its axis. Okay. So, next we discuss field of a uniformly charged ring on its axis. Okay. So here consider a ring. Suppose a ring, and the center C, and suppose this axis. Okay, and here the radius of the ring, say that is A, and calculate the electric field at this point P. Okay, here at point P, E in that direction, electric field. Okay, so suppose the center of that circular ring to point P, the distance will be x. Okay, so the electric field at point P, that is EP, that is 1 over 4 pi epsilon naught, or say that constant, Coulomb's constant, charge times x by a square plus x square whole to the power 3 by 2. And now this distance, okay, is very important. Okay, charge ring, so charge are placed on the ring. Okay, plus minus charge are placed in the ring. Okay, next, and electric field and potential of a uniformly charged sphere. Next we discuss electric field and potential of a uniformly charged sphere. Okay. So here, if I consider, suppose there is a charge sphere, and suppose there is an electric field, and that is a r some distance, and at that surface of that charge sphere, here suppose this r is equal to, choose a value of r is equal to small r. At that point, electric field be the maximum. Okay, and inside that sphere, that at the center electric field will be the zero, when from the center towards the circumference the electric field should be increased, and after the circumference electric field will decrease. Okay, so here E that is equal to some value of k q over times r by r cube. For these are small r must be less than capital R, and in that case outside of that sphere, that is q by r square. So small r is much greater than capital R. So what is the value of potential here? So the potential, that is the two value here inside the sphere, that is q over a, sorry, not 4 pi, 8 pi epsilon naught r. Okay, that is 3 minus small r square by capital R square, and the small r must be less than capital R. And outside the sphere, that is 1 over 4 pi epsilon naught q over small r. Okay, the small r must be greater than capital R. And here the graph is actually look like this. And that point, here the potential V, the small r, that is at that r, that's the graph is look like this. This is a V value. Okay. So now another concept, that's a charge sphere and charge spherical cell. Okay. Next concept we discuss, electric field and potential of a uniformly charged spherical cell. At that point, inside the cell, electric field here with a zero. Okay, so small r must be less than capital R, 0, but outside, that is 1 over 4 pi epsilon naught q over smaller square, that is the outside. And this graph is look like this. That is inside here, that is R with a 0, that is okay. Inside electric field 0, outside E proportional to 1 over R square. Okay, so what is the potential? The potential be, that is some constant k q over R, when small r must be less than capital R, and here some constant k q over small r, and is smaller is must be greater than capital R. And the potential now, if there is a electric field in E, and suppose the potential represents the green color V, the potentials look like this, flat, constant. Okay, inside the potential be the constant. Okay, if electric field be the 0, so V potential be the constant. Okay, now the basic application of Gauss's law. Okay, so first application is that field of a line charge. Obviously, field means electric field. Field of a line charge E, that is lambda by twice pi epsilon naught r. Lambda is the line charge density. Okay, field of a infinite charge sheet, that is E, that is a sigma over twice epsilon naught. Okay, and the field of an the vicinity at conducting surface, at conducting surface, that is E equal to sigma over epsilon naught. Okay, that's the basic three application. Okay, that is very important in board exam, and this is only one short of summary class, or you can say that a formula sheet. Okay, so the end of class here. Okay, if you have any doubt, please ask in comment section. Next class we discuss on capacitor and capacitance. Okay, just discuss only formula here. So we meet again in the next class. Thank you.